today we're getting into parallel and perpendicular lines. Parallel lines have the same exact slope, but a different y-intercept, so they never cross each other. So it could look something like this. Let's see. Well, let's see if anything shows up. There we go. So they have the exact same rise over run. Perpendicular lines, they intersect at a 90-degree angle. So their slopes are the negative reciprocal of each other. And we'll talk about what that means in a little bit here. But we start with the parallel stuff. Are the graphs of y equals negative 1/3 x plus 5 and 2x plus 6y equals 12 parallel? Explain. The big thing is, do they have the same slope but a different y-intercept? Now the first slope is negative 1/3. To figure out the slope of the second line, we got to get y by itself. So we know some tricks to move stuff around, like we can move 2x to the other side by subtracting it. So it'd be 6y equals negative 2x plus 12. And then we don't want that 6 there, so we would divide it. So it could be y equals 2/6 reduces to 1/3. So negative 1/3 x 12 divided by 6 is 2. So the slope of this line is negative 1/3. The slope of the first line was negative 1/3. They have the same slope and different y-intercepts. So yes, because they have the same slope and different y-intercepts. So if their slope is different in any way, they are not parallel. So let's try this one. Are the graphs of negative 6x plus 8y equals negative 24 and y equals 3/4 x minus 7 parallel? There's our first slope, 3/4. Let's check this one. We gotta get y by itself. So we'll add the 6y to the other side. 8y equals positive 6x. I think I said y, but I meant x minus 24. And then we'll have to divide by that 8. 6/8 reduces to 3/4. X 24 divided by 8 is 3. So again, yes, they are parallel because they have the same slope and different y-intercepts. All right. Write an equation for the line that contains this point and is parallel to y equals 3/5 x minus 4. So remember, parallel lines have the same slope. So what's the slope of this line? The 3/5 or the negative 4? It's the 3/5. So we use that same slope, but we use this point. So my recommendation is to put that into point slope form and then just move it into slope intercept form. So here's our point, here's our slope. So if we were dropping it into y or slope or point slope form, it'd be y minus our y coordinate, which is the 1, equals our slope, 3/5, and then x minus our x coordinate, 5. Now it doesn't tell us which form to put it in, so maybe they intended it to be point slope, and in that case, we would be done. But they didn't. They wanted it in slope intercept form, they always do. So to do that, we're just going to distribute that slope, which would give us 3/5 x minus 3/5 of 5 is just 3. And then slope-intercept form is just y equals. So we would also have to get rid of that minus 1. So we have y equals 3/5 x minus 2. Hopefully that shows up. Nice. Now this is your slope-intercept. And that is what they wanted. But let's go next level. You guys are next level humans. Let's also get it in the standard form. So remember, standard form is no fractions, and the x and the y on the same side. So to clear the fractions, we can multiply it out, multiply by 5. So 5 times y is 5y, 5 times 3/5 would be 3, and 5 times 2 is 10. What's going on here? All right. And then the last thing we have to do, we've cleared fractions, get the x on the other side with the y. So to do that, we would subtract 3x. So negative 3x plus 5y equals negative 10. Here it is in standard form. Man, if you can do all that, you're in great shape. Great shape. I gotta sneeze. All right, there we go. That cleared up some stuff. Moved around the furniture. All right, here we go. It's got this point and is parallel to y equals 3x plus 9. Again, all we use from this is the slope, which is 3. So we're using this point and the slope of 3. We're going to write it in the 3 forms. First, get it in the point slope. Y minus negative 6 would change to plus 6 equals our slope, 3 times x minus our x coordinate is 2. Here it is, point slope form. We're going to now get it into slope-intercept form. So we'll distribute the 3. 3 times x is 3x. 3 times negative 2 is negative 6. And then we just want y equals. So we'll subtract 6 from both sides. Y equals 3x minus 12. This is your slope-intercept form. Now, if we were to go into standard form, no fractions, done. But the x needs to be on the side of the y. So we would just subtract the 3x to get it to the other side. Negative 3x plus y equals negative 12. There it is in standard form. Great, great. We're halfway there. We've done parallel lines. Now we're going to do perpendicular. So perpendicular, the slope is the negative reciprocal, which essentially means it's the opposite. So if one is positive, the other is negative. Reciprocal means you just flip the fraction upside down. So if you had 2/3, you flip it and you make it the opposite. So if this was positive, you make it negative. That's it. The trick comes like if you had negative 1/2, you make it the opposite, so it'd be positive, and you flip it, it becomes 2/1, which is really 2. That's about as tough as it can get. So let's try this out. Which equation describes a line that contains 0, negative 2, and is perpendicular to y equals 5x plus 3? First of all, let's figure out what the perpendicular slope would be. This slope is 5, which is 5/1. We need it to be the opposite, so it would have to be negative, and you flip the fraction, it'd be negative 1/5. So let's see what options we can get rid of. Which ones do not have a slope of negative 1/5? This one's out because the slope is 5. This one has positive 1/5. We need it to be negative 1/5. This has positive 1/5. We need it to be negative 1/5. This one has negative 1/5. Yay! Now, you're not going to have a multiple choice question like that from me, so you would actually have to know how to then substitute that back in and solve the equation. Now, this says you have a point at 0, negative 2, which that would be your y-intercept. So that's why you have the minus 2 there as well. But they're not always going to just throw the y-intercept at you. So we're going to do what we did with the parallel ones, except the only difference here is you change that slope. Write the equation of the line that contains 1/8 and is perpendicular to y equals 3/4 x plus 1. Here's our slope. Our new slope would be the opposite, so it'll be negative, and you flip it, the reciprocal, 4/3. So we're going to use this slope and this coordinate. Let's get it into point slope form first. Y minus 8 equals negative 4/3 x minus 1. This is point slope form. Now this one's going to be a doozy because we're going to have decimals or a fraction, and that's okay. So if we distribute this, y minus 8 equals negative 4/3 x plus 4/3. Now it's going to be pretty hard to add 8 to that, as it is. If you want, you can certainly turn this 4/3 into a mixed number. You can make it 1 and 1/3. If you'd like, you can do that. And then you can just add 8. 1 and 1/3 plus 8 would be 9 and 1/3. Or if you wanted to turn that back into an improper, you could say y equals negative 4/3 x. 3 times 9 is 27, plus 1 is 28 thirds. So these are both fine as far as your slope-intercept. But on a problem like this, where I know it's going to come out to a fraction, because when you multiply that in, it doesn't work out to a nice even number, I like to go from here to standard form first, and then go back into slope-intercept at the end. So here we would multiply by 3, which will give us 3y minus 24 equals negative 4x plus 4. Then we could add the 24, 3y equals negative 4x plus 28. And then I suppose you could go slope-intercept form right here by dividing everything by 3, which would give you y equals negative 4/3 x plus 28 thirds, which is the same thing we got over here. Also from that step, the 3y equals negative 4x plus 28. It'd be pretty easy to go to standard form from there, because you could just add the 4x to the other side, which would give you 4x plus 3y equals 28. This is your standard form. But you could get that from this bottom blue part too. It's pretty challenging stuff to move these equations around. There's a lot that goes into it. A bike path for a new city park will connect the park entrance to Park Road. The path will be perpendicular to Park Road. Write an equation for the line representing the bike path. What's going on with their pictures here? All right. Okay. So we want it perpendicular. So let's figure out the slope first. We pick any 2 points to calculate slope. That's up to over 1. So the original slope was 2 over 1. Our new slope, you flip it and you make it the opposite. So our new slope will be negative 1/2. We also need the coordinate. The coordinate for the new park would be at 0, 4, the park entrance. Now, it intercepts the y-axis, so they gave us the y-intercept. Oh my gosh, that was so nice of them. We have the new slope, we have the y-intercept at positive 4, so you could just say y equals negative 1/2 x plus 4. You can get there by doing the point slope form and turning it into slope-intercept form, but if they're giving you the y-intercept, just take it. Let's see part B here. A second bike path is planned. Whoa! It's going to be parallel to Park Road and will also contain the park entrance. Now, I remember that park entrance was 0, 4, which again gives us the y-intercept. Something x plus 4. So it said it's going to be parallel to the initial one, and the original slope was positive 2, so it would have the same slope. So it would just be y equals 2x plus 4. Parallel, same slope, perpendicular, negative reciprocal. Okay, it's tough. I'll give it to you. It's tough.